Hello students. So for this session, this is the part 2 of the mathematical systems, and we are going to discuss about the different applications of modular arithmetic. So the first topic on the applications of modular arithmetic is the International Standard Book Number. So in an ISBN, the first three digits are 978. The next digit indicates the country in which the publisher is incorporated, 0 and sometimes 1 for books written in English. The next 2 to 7 digits indicate the publisher. The next group of digits indicates the title of the book, and the last digit or the 13th one is called a check digit. So below is an example of an ISBN number. So we have 978-316-1484-100. So the formula for the ISBN 13 check digit are labeled from left to right as D sub 1, D sub 2, D sub 3 until D sub 12, and X as the last digit or the 13th. The check digit X can be verified using the congruence formula below. So this is now the formula in how to determine if the ISBN is a valid number. So we have this X is congruent to 10 minus the quantity of D sub 1 plus 3D sub 2 plus D sub 3 plus 3D sub 4 plus D sub 5 plus 3D sub 6 plus D sub 7 plus 3D sub 8 plus D sub 9 plus 3 times D sub 10 plus D sub 11 plus 3 times D sub 12 modulo 10. So remember, if X is equal to 10, then it means that the check digit is 0. So let us try to have these examples. Letter A, determine the ISBN check digit for the book How Mathematicians Think by Beers, William, 2007. The first 12 digits of the ISBN are 978 0691 12738 X. For letter B, there is a purchase order for the book The Mathematical Tourist by Ivers Peterson with ISBN 9780760732616. Verify if the ISBN is valid. So for letter A, what we're going to do is we need to find the 13th digit, which is the check digit. So we substitute from the formula. We have X is congruent to 10 minus, we just have to substitute all of the values. So remember that the first digit refers to D sub 1, and then the next would be D sub 2 until the last digit represents D sub 8. So upon substituting, we have X is congruent to 10 minus the quantity of 9 plus 3 times 7 plus 8 plus 3 times 0 plus 6 plus 3 times 9 plus 1 plus 3 times 1 plus 2 plus 3 times 7 plus 3 plus 3 times 8 modulo 10. So we have X is congruent to 10 minus the quantity of 9 plus 21 plus 8 plus 0 plus 6 plus 27 plus 1 plus 3 plus 2 plus 21 plus 3 plus 24 modulo 10. So getting the sum of all of these terms would give us 10 minus 125 modulo 10. And then we get 125 modulo 10, that would give us 5. So 10 minus 5 would give us 5. So it means to say that the 13th digit or the x, the value of the x that we are looking for is 5. Okay, let's go to the next example. So we need to verify if the ISBN which is given is valid or not valid. So again, we just have to substitute the values of these ISBN to the formula. So remember that the 13th digit is 6, so which means that from D sub 1 to D sub 12, under the operation modulo 10, then it should be equal with 6. So upon substituting, we have 6 is congruent to 10 minus the quantity of 9 plus 3 times 7 plus 8 plus 3 times 0 plus 7 plus 3 times 6 plus 0 plus 3 times 7 plus 3 plus 3 times 2 plus 6 plus 3 times 1 modulo 10. Or we have 6 is congruent to 10 minus, this is 9 plus 21 plus 8 plus 0 plus 7 plus 18 plus 0 plus 21 plus 3 plus 6 plus 6 plus 3 modulo 10. Or that is 10 minus, so getting the sum of these would give us 102 modulo 10. Or we have 102 under modulo 10 is 2. So subtracting 10 and 2 would give us 8. So take note that here, the 13th digit is 8. And since from the given ISBN it's 6, then it means to say that the ISBN is not valid. Now we also have this ISBN 10, no? Or International Standard Book number 10. So there are books with ISBN 13 and ISBN 10. So the last discussion was all about ISBN 13. Now, for this, we have the ISBN 10 formula, and it is given as x is congruent to 11 minus the quantity of 10 d sub 1 plus 9 d sub 2 plus 8 d sub 3 plus 7 d sub 4 plus 6 d sub 5 plus 5 d sub 6 plus 4 d sub 7 plus 3 d sub 8 plus 2 d sub 9 modulo 11. So again, the same concept. The last digit of the ISBN will indicate the check digit. So let's have this example. The ISBN 10 for the math world is 08493964009. Now let's verify if the ISBN is valid. So we just simply substitute all the values. So take note that here in the ISBN 10, the first digit, which is 0, is the D sub 1. 8 is the D sub 2, and so on. So in which 9 is the check digit. So upon substituting, so our x is 9, is congruent to 11 minus 10 times 0 plus 9 times 8 plus 8 times 4 plus 7 times 9 plus 6 times 3 plus 5 times 9 plus 4 times 6 plus 3 times 4 plus 2 times 0 modulo 10. Or that is equal to 9 is congruent to 11 minus the quantity of 0 plus 72 plus 32 plus 63 plus 18 plus 45 plus 24 plus 12 plus 0 modulo 10. So getting the sum of the terms in the parentheses would give us 9 is congruent to 11 minus 266 modulo 11. And then getting the value of 266 modulo 11 would give us 2. And so we have 11 minus 2 would give us 9. So which means to say that the 10th digit is 9. So with this, we could say that the ISBN is valid. The next application is all about the Universal Product Code. So when we say UPC or Universal Product Code, it is a 12-digit code denoted by this A, and then we have C, 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 and X. That usually accompanies the barcode of a product. So for the universal product code, the last digit or the 12th digit, which is the X, is the check digit that can be computed using the formula. So we have X is congruent to 10 minus the quantity of 3A plus C plus 3C 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 modulo 10. So remember that the C here, okay, the first C on the formula indicates the first C on the UPC code, okay, and so on. So which means that this first C here indicates the first C in the UPC code. The second C indicates the second C in the UPC code, and so on. So let us try to have an example. Say the UPC code is 69277198116-1. Now verify if the UPC is valid. So the same principle with the ISBN, we substitute all the necessary values in the UPC formula. So X is congruent to 10 minus 3A plus C plus 3C 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 modulo 10, or that is equal to X is congruent to 10 minus the quantity of 3 times 6 plus 9 plus 3 times 2 plus 7 plus 3 times 7 plus 1 plus 3 times 9 plus 8 plus 3 times 1 plus 1 plus 3 times 6 modulo 10. Or that is X is congruent to 10 minus the quantity of 18 plus 9 plus 6 plus 7 plus 21 plus 1 plus 27 plus 8 plus 3 plus 1 plus 18 modulo 10. So getting the sum of all of these terms would give us X is congruent to 10 minus 119 modulo 10. Then getting the value of 119 modulo 10 is 9. So which means to say that 10 minus 9 is 1. So what does it mean? Since our X is equal to 1, now it means to say that our UPC is valid. Okay, because the last digit of the UPC is 1. Now, the next application is about the credit cards. So in the credit cards, we have this 16-digit number that indicates the number in the credit card. So how do we verify if these digits are valid? So we make use of the Luhn algorithm, or sometimes it's also known as the modulo 10 algorithm. So the Luhn algorithm is calculated as follows. Number 1, beginning with the second to the last digit and reading from right to left, double every other digit. Number 2, if ever a digit become a two-digit number after its having been doubled, treat that number as two single digits. And number 3, find the sum of the new list of digits. If the final sum is equal to 0 modulo 10, then it means that the credit card is valid. Now let's use the concept of Luhn algorithm to verify if a certain credit card number is a valid number. For example, John received his credit card with number 523482133410 1496. Verify if the credit card is valid. So using the algorithm, so the first step is beginning with the second to the last digit and reading from right to left, we highlight every other digit. So remember, we have this 5234, 8213, 3410, 1496. So starting with second to the last digit, and that is 9, and we are going to highlight that number. So that's why we bold it with a color black. And then we try to highlight every other digit which starts from the number 9. So the next uh, digit which is after the number 9 is 1. So that's why we highlight 1. And then we have another 1, 3, 1, 8, 3, 5. So we are going to highlight all of these digits. And then step 2 is to double each of the highlighted digits. So we have 18, 2, 2, 6, 2, 16, 6, and 10. The rest of the digits which are not highlighted will remain. Step 3, finally add all digits, treating two-digit numbers as two single digits. So for example, we have 10, we are going to treat this as two single digits. So we have 1 plus 0. Then for the 6, and then we have for 16, since this is a uh, two digit, no, 16. So we are going to make this into a two single digit. So that's why we have 1 plus 6. And then we have 2, and then we have 6, and then we have 2, 2 for the 18. So it is separated as 1 plus 8. And we are going to add all of them. So which means we have 1 plus 0 plus 2 plus 6 plus 4 plus 1 plus 6 plus 2 plus 2 plus 3 plus 6 plus 4 plus 2 plus 0 plus 2 plus 4 plus 1 plus 8 plus 6. And that would give us 60. Next, take note that 60 is congruent to 0 modulo 10 because we know that 60 under modulo 10 is congruent to 0. Or when we get the remainder, when 60 is divided by 10, we know that the remainder is 0. And so we say that John's credit card number is valid. Now, if the value is not congruent to 0 modulo 10, then we could say that the credit card number is invalid. So that is how we determine if the numbers on the credit card is valid or not. The next application is all about cryptography. So we make use of the Caesar cipher in cryptography. Now, cryptography is the process of converting data or information into codes. Primarily for the purpose of keeping it secured, it involves encryption and decryption. Encryption basically converts a message into meaningless and usually unreadable formats that only the intended recipient can understand. Decryption is the process of recovering the encrypted information. The oldest method of encrypting and decrypting information is the shift ciphers method. Every letter of the alphabet is replaced by another letter which is at some fixed number. It is represented as, so if you're going to make use of the encryption cipher, so the formula is C equals the quantity of P plus K modulo 26. For decryption cipher, the formula is P equals the quantity of C minus K modulo 26, where K is called the key shift and it represents any number. So for K, no, it's up to you what value, so any number will do. So that's the key shift, or sometimes that's also called the passcode. So here in the letters of alphabet are replaced by the numbers. So here on this table, okay, these are the corresponding values of the letters in the alphabet. So we start with A as 0, B as 1, C as 2, D as 3, and so on until Z equals 25. So for example, we encrypt the message I love you and decrypt it afterwards using the key shift of 10 or the passcode of 10. So take note that for encryption, we make use of the formula C equals the quantity of P plus K modulo 26. So on the table, we are going to highlight the letters that we are going to need for the encryption. So we start with letter I, so which means to say that our P is equal to 8. Then using the formula, C equals the quantity of 8 plus the key shift, which is 10, modulo 26. So 8 plus 10 would give us 18, modulo 26. So since we know that 18 is less than 26, then C is equal to 18. And then going back at the table, 18 is letter S. Now for letter L, so P is equal to 11. So using the formula, 11 plus 10 modulo 26 would give us 21, or our C is equal to 21. So 21 is letter V. For letter O, our P is equal to 14. So using the formula, 14 plus 10 modulo 26, that is 24 modulo 26, or that is 24, and 24 corresponds to letter Y. For letter V, our P is equal to 21. So that is 21 plus 10 modulo 26, or that would give us 31 modulo 26. So we apply the modulo because 31 is greater than 26, or that is 31 minus 26. So the value is 5. And 5 corresponds to letter F. For letter E, our P is equal to 4. So which means to say that is 4 plus 10 modulo 26, or 4 plus 10 would give us 14. So 14 corresponds to letter O. For letter Y, our P is equal to 24. So using the formula, 24 plus 10 modulo 26 would give us 34 modulo 26. So we apply modulo because 34 is greater than 26. So we subtract 34 and 26. That would give us 8. And 8 corresponds to letter I. For letter U, P is equal to 20. So using the formula, 20 plus 10 modulo 26 is result to 30 modulo 26. And using modulo 30 minus 26, that would give us 4. And 4 corresponds to letter E. So we have already encrypted all the letters. So the message, which is I love you, can be encrypted as SVYFOIYE under the key shift 10. So again, when we say encrypted message, this is a meaningless message, and only the recipient can know the meaning of this message after decrypting the message. So this is now the encrypted message. Now, if you want to decrypt this message, so we make use of the decryption's cipher, okay, denoted by the formula P equals the quantity of C minus K modulo 26. So here, this is our encrypted message. And if we want to decrypt this, so we know that the key shift is 10. So again, we assign all the values of these letters from this table. So for letter S, so we let now our C be equal to 18. And using the formula, 18 minus 10 would result to 8, or our P is equal to 8. And 8 corresponds to letter I. For letter V, our C is equal to 21. And so we have 21 minus 10 modulo 26. That would give us 11 modulo 26. For our P is equal to 11. And 11 corresponds to letter L. For letter Y, so our C is equal to 24. So using the formula, 24 minus 10 modulo 26, that would give us 14 modulo 26. And 14 corresponds to letter O. For letter F, our C is equal to 5. So using the formula, we have 5 minus 10 modulo 26, or our P is equal to negative 5 modulo 26. So to make this positive, so we add this by 26. So that is negative 5 plus 26 would give us 21. And 21 corresponds to letter V. For letter O, our C is equal to 14. So using the formula, we have 14 minus 10 modulo 26. So we have 4 modulo 26, and 4 corresponds to letter E. For letter I, our C is equal to 8. So using the formula, 8 minus 10 modulo 26 would result to negative 2 modulo 26. Adding this by 26, so that would give us P equals 24, and 24 corresponds to letter Y. For letter E, our C is equal to 4. So using the formula, we have 4 minus 10 modulo 26. So 4 minus 10, that's negative 6 modulo 26. And then to get the positive, we add this by 26, which is negative 6 plus 26 will result to 20. And 20 corresponds to letter U. So as we try to decrypt the meaning of this message, we found out that the meaning would be, I love you. So that is all about cryptography using the Caesar's cipher method. So thank you for listening for the mathematical systems.